Welcome to Spring LIB.
So we are given that there are two weights acting downwards, 20.5 Newton and 112 Newton. From here on, we'll just combine these two into a single force of 132.5 Newton. Now this is the weight of the hand and the weight combined. Now the the forearm is raised at an angle of 43 degrees from the horizontal. Because the bicep force acts perpendicular to it, now we can see that because this angle is 43 degrees, this angle must be 90 minus 43 degrees because this is a right angle. Now because this is a right angle, we know that this angle must be 90 minus, let's say if this angle is alpha, this would be 90 minus alpha, and that would be 90 minus of 90 minus 43, which would be 43 degrees. Hence, this angle is 43 degrees. Now, let's call this vector B for bicep. Let's write down the vector form of vector B. Now, the x component of vector B is negative, but the y component is positive. And because this angle is 43 degrees, its x component would be its magnitude B, which is 232, multiplied by, the magnitude is 232 Newton, multiplied by sine 43 degrees I hat. But because this is negative, we put a minus here. Let me erase this part here. Yeah, that is 232. Plus, our y component would be 232 cos 43. And because it is positive, we just leave it like that. This turns out to be minus 158.22 I hat plus 169.67 j hat. Now, let's say our elbow force is vector E, force E. Now, the total system is in equilibrium, and hence vector B plus vector E plus the weights, which is this, let's call this vector W. W bar should be 0. Now we can easily see that vector W is minus 132.5 j hat because it's completely vertical and downwards. Therefore, the elbow vector would be minus of B plus W. Hence, minus of, we can write B plus W by adding individual components. It would be minus 158.22 I hat plus 169.67 minus 132.5 j hat, which turns out to be 158.22 I hat minus 37.17 j hat. Hence, it looks something like this. Now, we need to find the magnitude of this vector. We can find it using the usual Pythagorean theorem, the square root of the sums of the squares of the numbers, the components, which is 158.22 squared plus 37.17 squared, which turns out to be 162.5 Newton. Now, to find the angle, we use the same tangent of the angle method. We simply say if this angle is theta, then theta is tan inverse of the y component divided by the x component, which is 37.17 divided by 158.22, which turns out to be 13.22 degrees. Hence, the elbow force acts at an angle of 13.22 degrees at south, I'm sorry, downwards from the x-axis.